Hey, Dr. Meunier here, doing a supplemental video for the Spring 2015 Genetics lecture course. This one's going to be on complementation, and what I've done here is I've modified my original lecture slide a little bit to make it more clear what's going on. So complementation is the idea that multiple loci can generate the same phenotype. And for example, let's just say you're a geneticist and you're doing what we call a mutagenesis screen, which is you're inducing mutations in some model organism, let's say Drosophila or C. elegans, and you're interested in some phenotype, let's say rapid cell growth, because you're interested in cancer. And let's say you expose your organisms to a mutagen, induce mutations, and you're screening them for different phenotypes. And what you're looking for is rapid cell growth, so maybe development of tumors, for example. And you find in your population, you find, say, 10 individuals that show a mutation that leads to rapid cell growth. And you want to know what's the genetic basis of these mutations. And one of the first things you might ask is, are these mutations at the same locus? So is the same gene for any of these 10 individuals causing the phenotype that I'm seeing? And so you might do a complementation test where you breed those two individuals together and look at their progeny and see if their progeny also have the phenotype. Okay, so there are two possible outcomes for this. Let's say, in this case, we have a mutation at the same locus, locus A. And when we breed these two individuals together, we get the same mutant phenotype, which tells us that, that these individuals are both having this phenotype because they have mutations at the same locus. If, however, we find that they are that the phenotype is caused by mutations at different loci in different organisms, then we can breed them together, and when we do that, we're going to generate a wild-type phenotype, which will generate, which is due to heterozygosity at both loci, because presumably we have a mutation at one locus and the other locus is wild type. At the same time, we have a wild type genotype at the first locus and a mutant phenotype mutant genotype at the second locus, such that when we breed these two together, we end up with heterozygosity at both loci, which generates the wild type phenotype. That's the idea of complementation.